So good afternoon, everyone. Thanks, everyone, for coming. My name is Justin Mattson. I'm a developer advocate working at Google, where I've been for the last about 4 years. And for the last 2 years of that, I've been working on the Android project, which is hopefully what all you are here to hear me speak about. And so the last 2 years on Android has been really exciting, really crazy. I expect it to get crazier and more exciting as time goes on, because that's all that's happened. And part of that excitement and craziness has been the fact that if we go back 2 years ago, Android was a software development kit and an emulator. Fast forward 2 years to today, and you can go out on the show floor and see around 50 devices from a variety of manufacturers running on a variety of carriers around the world. And what that means is that we've had an explosion in the number of form factors and screens and configurations that are out there, which is really awesome, because Android has become the optimal device for millions and millions of users across the world. Millions and millions of users that you can now reach as developers for Android. The other side of that, of course, is a challenge. These devices are different. They run different versions of Android. They have different screens. So how can you as developers meet this challenge? And that's what we're here to talk about today. So a little housekeeping before we really get into the main goal. As with the other sessions, we're using Wave to both take notes as well as discuss the presentation as it's going on. If you'd like to participate in the Wave in any of these capacities, please go to tinyurl.com/iocasting or scan the QR code. But be quick about it, because I've got to keep moving. So, as I was saying, there's a huge opportunity out there to reach a very large number of users. And in order to realize that opportunity, you have to meet a challenge, which is running well across all these devices. Now, the good news that I'm also here to tell you today is that meeting this challenge is not really that hard. So I want to go over a set of considerations as you're building your Android applications that will give you a strong foundation for running well across all devices in the Android universe today. And when I think about this task, I think about it in two vectors. The first vector is screen or UI compatibility. So we'll talk about that first, and mainly that has to deal with the way you're creating layouts and drawables for your project. And underlying the layouts and drawables that you'll use for your project is the resource system, which is the foundation to build on and what I'll talk about first. The second vector of compatibility that I think about is API level compatibility. So this means what APIs are available to you as a developer from the Android system. So I'm not going to talk about specific APIs that are or are not available, but I will talk to you about how to figure out what you have available and then how to adapt your program behavior based on that. And finally, a word about testing, because I am talking about running on many, many devices, and testing is going to be essential. But I'll also do a little preview in saying that you don't have to have all of those devices. In this first vector of screen or UI compatibility that I'm talking about, I first need to talk about the resource system. Now, the resource system might be something that many of you are familiar with, but I really want to cover this because it's essential as the basis for building a compatible Android application. So the resource loading system is there to help you out. It is there to load the resources that are most appropriate for the current device configuration that your application is running on. So the question is, how does it pick those resources? It picks those resources based on a number of qualifiers. And these qualifiers you use to label your bundles of resources so that the system can find them. So I'll refer to these resources as bundles of resources or directories that live within the resource directory of your project interchangeably. So the other thing to realize is that the configuration of your device can change while your application is running. And if so, the system is going to restart your process in order so that the resource system can provide all the new graphics and strings and everything that you need. A resource configuration change might come in a number of forms, and I'll mention one of those a little bit later. So I mentioned resources are specified by some qualifiers that correspond to attributes of the configuration of your system. And what I want to do is go through a few of these that are really important for this first vector of screen or UI compatibility. The first qualifier is screen size. And what do I mean when I say screen size? By screen size, I mean actual physical dimension of the screen that your application is running on, not something like, say, screen resolution. And types of resources that are most concerned with screen size are typically things like layouts. Because if you have more physical space on your screen, you may choose to include different UI elements or arrange them in a different way. Now, for Android devices out there, there are actually many, many different screen sizes. Some differ only by 1/10 of an inch. And these small differences aren't all that consequential most of the time. So Android asks you not to consider every individual screen size, but rather different buckets. And by focusing on this much smaller set of different buckets, you'll greatly simplify the task of picking layouts that make sense for these different screens. The second qualifier to talk about is screen orientation. You might also think of this as aspect ratio. So this is your screen wider or taller? And pretty obviously, the types of resources that are concerned with this are layouts. Sometimes drawable resources like images that you'll include, but more often than not, layouts. And I mentioned before that the configuration of a system can change while your application is running. Orientation is one of those configuration parameters that is actually pretty likely to change. And who's tried to stop the system from killing their application when the orientation changes? OK, I think more of you have probably tried to do this. But don't do this. The system is doing this for your own good. Because otherwise, you have to figure out what all the different resources that you should load. And so a change in screen orientation might be triggered by a hardware change, like a user flips out a keyboard on the G1 or the Droid. Or it might be the result of an accelerometer event. The sensors detect that the screen orientation has changed. And then when your app restarts, it gets this opportunity to load the optimized layout for the new configuration. So don't disable it. Work with it. Not against the system. The system's probably going to win. And the third qualifier I want to talk about is screen density, which is the other attribute of a screen that we're interested in. And quite simply, density is the number of pixels per whatever unit of measure you want to use. Now, notably, the density qualifier works differently than the previous two qualifiers that I mentioned. Instead of being an exact match system, the density qualifier works on inexact matches. The system attempts to find a best fit for the existing configuration. And for best fit, this Android system asks you to construct 3 sets of resources at this point. Resources for low density, medium density, and high density screens. And the types of resources that you're most apt to create customized versions with are the drawable resources, the images that are going to be rendered to the screen. And so what does best fit in this case mean? Well, best fit was designed to mean the density qualifier that is closest to the actual screen density that the app is being run on, and the one that the system thinks will look best. When talking about this qualifier, it's important to note a critical bug in Android 1.5 with respect to this qualifier. And that is the fact that Android 1.5, unlike the design says, selects the first match for the density qualifier instead of the best match. So if you're running on a medium density screen, this might be the bundle of drawables that is selected by the system to be displayed. And then the system is going to scale all of these. And if they're high density resources, it'll have to downsample. So this is quite simply a bug, but then you would ask, well, what is the order of resources in the bundle? And this is determined by the way the packaging tool packaged up the actual application binary. And what the packaging tool puts in the binary first is going to be determined by the order in which the host operating system of the packaging tool listed the resources directory to it. Now, unfortunately, different operating systems list things differently. And it's not actually even guaranteed that 2 runs on the same operating system will produce the same results. So the takeaway here is that if you provide these customized resources and support Android 1.5, the way that the density qualifier works is completely indeterminate. There is a way out of this problem, which is going to bring us to the version qualifier. So before we go over how you can use the version qualifier to fix the previous issue, let me describe how it works and why you might care about it. So independently of the great things that it can do to work around this other bug, the version qualifier is most useful if you're trying to adapt to different styles presented by different versions of the operating system. So between Android 1.6 and 2.0, for example, the default look of icons on the home screen changed from being sort of 3-dimensional, as you can see on the right, and went to being flatter, more 1-dimensional in 2.0, as you can see on the left. And also over time, you might imagine that some sort of layout conventions change as well. So you might decide to include custom layouts and custom drawables for later or earlier versions of the system. Now, similar to the way the density qualifier works, the version qualifier uses a best match approach that is basically an inequality. And the inequality says the best match will be the version qualifier that is closest to my own without exceeding it. So if you're running on Android 2.0, which is version 5 of the operating system, and it sees a version 3 directory, and nothing higher between 3 and 5, it will consider that a match. But if there's a version 6 directory, that will not be a match, since it exceeds the current SDK version of the system that it's running on. Now, 2 more small items before we talk about how you can use this to work around the density qualifier problems is that the version qualifier has bugs of its own. So on Android 1.5 through 2.0, the version qualifier does exact matching instead of inexact matching. So Android 1.6, which is version 4 of the operating system, will not consider the v3 directory a match. It will look only for v4, or of course an unqualified resource directory. The second thing to be aware of is Android 2.0 the resource system in Android 2.0 thinks that it's version 6. So 2.0.1, which actually is version 6, also thinks it's version 6. So for the resource system, essentially, version 5 never happened. Now, happily, 2.0.1 and above, these bugs are fixed. Everything works great. So with these caveats in mind, how can we get to our goal of having the right assets selected for Android 1.5 and the medium density screens that it runs on? So we can do this, or well, this is the beginning of the solution anyways. We'll have our medium density resources, and we know that Android 1.5 is only ever going to run on a medium density screen. We'll have our medium density resources and suffix them with v3. So we know for sure this directory is going to be picked by Android 1.5 now. And actually, were it not for these 2 bugs that I was just talking about, we'd be done. But now there's an issue because version 4 and version 5 of the platform are not going to select this directory. And with the structure that I have listed here, they actually will then use the low density or the high density resources. In order to get around this, we need to make a copy of the medium density resources. And as long as our medium density resources are actually the same across all of the versions of the platform, we're done. If you want to include more customized resources for different versions, it gets a little more complicated. I'm not going to go over that, but applying the rules and caveats that I've described here makes it pretty straightforward. So unfortunately, to support optimized drawables across all versions of the platform, you need some resource duplication that's going to inflate the size of your application package. But that should give you a pretty complete overview of the parts of the resource system that you need to consider for this first vector of UI or screen compatibility that I've been talking about. And now that we understand that, I want to move on and build on that and talk about how some specific types of resources are handled. The specific type that I want to cover is image resources, because a large part of many people's applications out there are involve images. So it's important first to understand what Android is trying to do with image resources and what the resource system is trying to accomplish. And that goal is that images, bitmaps that you include should be displayed as the same physical size across all devices out there, regardless of screen configuration. And this is great, because that means if you define your image view to take a certain number of density-independent pixels, the system is going to take care of all this math and everything for you to figure out how many actual pixels on the screen that view should take up. Now, a secondary consideration is whether or not you want to include optimized resources for every density bucket that's out there. And for some types of images, this may not actually be necessary. If you have low complexity things, like a square or a circle or something like that that's going to scale pretty well, it might not be worth the extra application package size. But for other images that have a greater deal of complexity or convey information based on 1 or 2 pixels, it's really going to be worth it to you to include optimized versions and take that extra time in the pre-build process. And to illustrate that, I want to walk through how the system might handle scaling in this case. So let's say I've included this nice image resource, very sophisticated and pretty, along with my application package. So I've got a smiley face, and I've rendered him here on my representative medium density pixel grid. Now let's say this is the only resource that the only version of this resource that I've included with my application. But what happens if then the application is actually run on a low density screen? So in the middle here, I have a low density pixel grid, and what I've done is overlaid the medium density pixels on it, and then tried to make some guesses about the pixels that would be chosen to be colored in. This is essentially your sampling algorithm, right? So you can see the choices that I've made here with my pretty simplistic sampling algorithm. While they still convey the overall character of the image, there's a significant loss of fidelity. And the other thing I want to do is select a slightly different sampling algorithm. And you can see that the fidelity lost here is actually much greater. Now, neither of these really represent what the system does, but the point that I want to get across is that what sort of fidelity is retained is highly dependent on the sophistication of the sampling algorithm. And also, that even with the best of intentions, there's only so much that the system can do with a limited number of pixels. And finally, the other part of this is that you can see that parts of this image, like the curves of the face or the nose that are dependent on just a couple of pixels, are the ones that have been impacted most greatly. whereas the sides of the face and the ears have more or less retained their character across all decisions here, because they're dependent on a greater number of pixels to convey information. So that's what will happen if you don't interfere with the system and the way it loads images in any way. It will rescale these things for you. But let's say you want to manipulate what the system does by default. Well, you're really sure that you want to do this? You probably shouldn't do this. Please, unless you're really, really sure, just let the system do what it was designed to do and help you out. But if you must, let's talk about breaking the rules. So the first thing to understand of how to break the rules is what the rules are by default. So by default, when resources are being loaded, you grab a bitmap factory object, for example, and say, create a bitmap out of this resource or this URI or something, and provide no bitmap factory options object, the bitmap factory options will be set to their defaults, which are something like this. And we're concerned with two of the options, the input density and the input target density. So the indensity is the density that the system believes the resource was designed for. So if it plucks a resource out of the medium density drawable folder, it's going to assume that this was intended for medium density. And then the in-target density is the density of the screen that this input is targeted to be displayed on. So typically the screen on the phone. And then whether or not the system is going to scale this when it's rendered to the screen is dependent on the ratio between these two values. So obviously, if you want to get around this, what you can do is provide your own bitmap options object and set the in density equal to the in target density equal to the density of the screen that you're running on. And basically, this will help you in those couple of situations, and there really aren't very many, where you want to override the system's default behavior and really render your image pixel for pixel. And the result in my previous example here was that I wouldn't have gotten any of these scaling effects, but it's going to take up a larger portion of the screen because I'm taking up the same number of larger pixels, which, as I said, generally isn't what you want to do. So 9 patches. Who's used 9 patches? Who wants to use 9 patches and doesn't understand them? OK, a few people. And so 9 patches are a really powerful type of image resource. And basically what they do is take your base image resource and layer some information on top of it. And the purpose of these things is so you can include fewer drawables in your package. Because the bit of information that you're layering on top instructs the system how to scale and manipulate this image so that it can fit larger or smaller sizes than it's currently designed for. So I'd really like to go over these. Unfortunately, my desire to do this is not sufficient to allow me to do so because I don't have time. So we're going to go through it really quick. Pay attention. Nine patches. So that's how they work. They're really great. You should look into them, and we'll try to get these slides that I didn't talk about at all up as soon as possible with greater description so they will be useful. OK, so I spent a lot of time on these graphics because I'm not a graphic designer, and I had to cut them out. So I've been talking about images and bitmaps and things like that. And so now I want to step back a bit and talk about drawables in general. So the bitmap resources that you include with your package are one of the things that's drawn to the screen. But drawables are a broader class and are quite simply anything that knows how to render itself to the screen. So in talking about drawables, I want to bring forward some classes that can help you out when you're writing your application. Can help you draw a user interface that is better optimized to the screen that you're running on, allows you to have a smaller application package size, reduce the amount of work that you'll need to do when creating your package, and generally make everyone happy. So this is, sort of a tips and tricks section. And the first type of drawable that I want to talk about is shapes. Maybe some of you are thinking, shapes? Oh my God, they're so basic. Why do we want to talk about shapes? Well, shapes are great because they're classes that know how to draw simple graphics primitives to the screen, like a circle or a rectangle or the special rectangle, a square. And what's great about these is that you can use them in a couple of ways. First of all, I've unzipped developers' applications before to find that they've included a number of drawables which are merely colored circles or colored squares, things like this, and for no reason they made their application larger, when they should have just used shaped drawables. And the second thing is that it's pretty common to want to form a composite type of drawable where you're using some basic shape and then actually some custom drawable, maybe like a company logo that you want to include on some different colored fields or something like this. So instead of having to go through the work at the beginning to create these, you can use shapes at runtime to draw great looking versions on the screen. And this is really facilitated by the shape classes because they have this handy draw method to help you building a custom view. And if you were going to build a custom view, like one that rendered my little Google I/O logo there on a green rectangle, you might do it something like this. So the first thing that this view class is doing is creating a new rectangle shape, and then in the constructor, I'm grabbing this logo from my application's resources. And then when it comes time to actually draw my view, render it to screen, I'm first telling the shape what size it needs to be, and then handing it the canvas that my view was handed by the drawing system. And then I'll simply draw my logo on top of that once it's finished. And the result is that I didn't need to include my logo on a green background and a red background and a blue background and textured and everything like that. I was able to include just the unique bit and then handle these generic operations in code at runtime. Another drawable type that can be really useful on this vector of screen compatibility is the scale drawable. And the scale drawable is a wrapper around another drawable that allows you more customized control of the way that drawable grows and changes as the screen grows or the aspect ratio changes. This can be particularly useful in places where one dimension of the underlying drawable is much more important than the other dimension. So for this, think things like a horizontal progress bar. The horizontal is actually much more important, and you'd like to grow that out as the screen gets wider, but you don't necessarily want to make it a whole bunch taller. Rather, you'd like to take that vertical screen space and do something more interesting with it. Similarly, dividers of vertical or horizontal varieties have a dimension that is certainly more important than the other. So basically, any place where one dimension is more important than the other is one where a scale drawable can help you out in making the UI look better, as well as reducing the number of actual drawable resources that you need to include. The next one I want to talk about is the level list drawable, which I think is a rather clever little beast. And so the level list drawable is a composite of other drawables that you include in your package. And what it does is logically groups these resources or other drawables into one element. And part of what this is doing is separating out your presentation from your implementation. So your implementation can be concerned with figuring out what state your drawable should be in, and then the level list will figure out, based on that state, what the exact presentation should be. An example that is really straightforward of using these is a status meter of some variety. So imagine you have a battery meter and you have drawables for different charge levels, but you don't have one for every charge level from 0 to 100%. And the drawable itself should just figure out which of the drawables that are its children it should pick to draw to the screen. And your code should just be concerned with setting the status of that drawable so it can figure out how to draw itself. There's some other kind of less conventional uses for this. You might use it for weather conditions, or perhaps if you're trying to pick what a drawable should look like on different UI themes, because there are a couple different UI themes out there for Android devices. And if you're using some of these less natural scenarios for level lists, you can define constants in your code that are going to make the code much more readable and logical in terms of setting what the level means and what it stands for. So the goal of this drawable is really to make your code easier and more readable and logically separate the concerns of presentation from the actual code implementation. And I want to walk through a quick example of using this because I really do like level list and think it's rather clever. So let's say that I have an application where I want to provide details of details for a sports game that's going to happen. And one thing that I'm worried about is what the weather's going to be like. And I want to render this attribute on screen. Now, logically, this part of the screen is always just weather condition, what it's going to be like. My code just wants to think about weather condition, set the condition, let the UI figure out the rest. So I've got my level list here defined in XML, which has a number of items. So the items have two attributes. They refer to a drawable resource. In this case, it was just bitmaps. And then they also have this max level parameter. And this is the maximum value that the level list is set to for which this drawable is appropriate. So for example, here I'm basically saying if the chance of rain is between 0 and 10%, I want to put the chance slight up there. If the chance of rain is between 10 and 40, okay, I'll say the chance is sort of good. So then if I want to use this in my code, it looks something like this. And it looks really simple, which is awesome. I've exported some of the switch statement complexity that I might otherwise have to this nice markup language that I don't have to clutter my code with. And I can even let my designers reconfigure this for me, and I don't have to worry about it. So I'm just finding the view that corresponds to my weather condition here. And then I'm setting the image level. And maybe I'll get the image level, which is the probability of rain, from some web service out there. And if you'd like suggestions on how to do this best, make sure to attend the first Android session tomorrow, which I saw a preview of, and it's actually really awesome. But anyway, so I'll call out to my web service and get the probability back, and then the UI element will figure out how to display itself. So if there's a good chance of rain, it might look something like this. If the chance of rain is pretty low, it might look as such. But I could also use this for something less conventional. I could use it for the sports teams here to control what icons. And for this, I would do something just like defining logical constants that correspond to the sports teams and then setting those to correspond to max level in my level list attributes. Oh, and a special thanks to the Open Clip Art project, which has some great public domain images that saved me probably a day of work trying to create a cloud with a sun behind it. I'm not a graphic artist. So talking about resources, talking about images and drawables, these are the main components of what you'll need to think about when you're thinking about screen compatibility, or this UI compatibility vector that I've been talking about. So there are a number of things in the system to help you out, the resource system, and also a simplification of the universe, collapsing the different screens and collapsing the different screen configurations into a handful instead of the myriad that are actually on the 50 devices out there. But of course, your application isn't just UI. There's probably some code that drives that UI. And the code that drives that UI is going to run on different versions of the Android operating system. Today, we have 3 major versions out there. We have Android 1.5, 1.6, and 2.1. And I'm here to tell you that multiple versions are the norm, not the exception. Sorry. So I think that we'll probably always have at least 2 major versions of Android out there. But this isn't such a terrible thing. And it's actually not that hard to deal with. So let's go over how we deal with this diversity, with this API diversity. And so basically what I'm going to talk about here is detection. And after the condition of the environment has been detected, you have any number of different ways that you can deal with that change. Or not that change, but deal with that situation. Don't worry, the API level isn't one of those things that will change while your application is running. That would be really bad. So the basics, so there are 2 types of API changes that we're going to consider. One is when whole new classes enter or leave the API, and the other is when individual methods get appended or removed or changed. But the basic strategy for dealing with both of these situations is the same, which is to insert yourself into the class loading and verification chain of command so that you can intercept any errors, realize what the error means, and then deal with it in your code appropriately. And so for dealing with class level changes, what we're going to walk through is using some static methods and members, which are basically going to poke the class loading system and say, tell me if tell me if this item isn't available. Then we'll catch any error that that system throws to us and adapt the behavior appropriately. And so by using a secondary class with some static methods, we'll avoid this kind of messy probing where we call class for name and type out the whole name, which we might mistype and get a false positive on, and all sorts of messy things. The downside of this, of course, is that we need more classes of either top-level classes or inner classes to help us out. And to deal with this, you might have just a host of inner classes in sort of whatever class hosts your detection code, or you might sequester them all in one package where they're kind of out of the way of the rest of your project. And one of these detector classes might look something like this. So I've got my class here called Canary. For anyone not familiar, Canary used to be used in coal mining to detect if dangerous gases were building up. So unfortunately for the canary, it would typically die, but the miners would come out alive. So my similar canary here in the digital age, my digital canary, is going to have a private static member that is of type whatever I'm looking for, whatever the new class is. And then I've got this static method, try new class, that tries to create a new instance of this class. Now, there are a couple of different ways that I could do this. I wouldn't necessarily have to create a new instance. There are some different ways to skin this cat, but this is the one that I'm fond of and going to choose for this case. So how does Canary integrate with the rest of my code? So if I've got my activity here, what I'm going to do is have this Boolean that tells me whether the canary is available. After I made these slides, I realized I probably should have said canary alive or not. And that sort of goes with the rest of the metaphor. So if canary is available and alive, I'll do one thing, and if it's not, I'll do another. So the first thing that I'm going to do is have my check APIs method here, which is going to call this static method in my Canary class. And when it does this, the class loader for Android is for the first time going to pull Canary into the memory, look at it, and go, do you work on this system? And if it does, my code's going to proceed, and I'll say the canary is available and alive. But if the class loader looks at it and says, wait a second, we don't have that, it's going to freak out and throw an error and say, oh, I can't load this class. So I'm going to catch that error and then note that the canary is not available, and also put in the log that the canary is not available, which will hopefully help with debugging later on if I find some odd application behavior and I see this in the log, I'll know that the compatibility mode code had been invoked. So this will help me deal with when whole new classes come in or go out of the API. But sometimes the API level changes are a bit more subtle than that. Sometimes they're just new methods, or maybe even just changed method signatures. And I think this case is a little bit trickier to deal with, but the same basic, two-phase strategy of detect and deal with is still being used. So in the detection phase, I have the choice of using reflection to see if a given class has a method available, or I can take the step to make my code version aware, which means I'll have some bit of code that has, this lookup table that says, in this version of the OS, I have these APIs available. In this version, I have these APIs available, et cetera, et cetera. And then that code can just look at the build version number. The downside of this, of course, is that this is pretty brittle. It's open to human error. And it means that when new versions come out, you're going to have to scramble and update this code. So once we've detected whether or not something is available, how are we going to create a class that works in this environment? Well, one way is that we can call the questionable method through using reflection. And this is going to result in fewer classes, because then my detection code can also operate on these underlying classes, and I won't throw any verification errors. The other option is to use some sort of factory pattern, which will figure out availability, and then based on that, load the appropriate class that implements an interface that only touches methods that are available on this version of the platform. So reflection is going to give me fewer classes. The factory method will give me more classes, but is somewhat cleaner in the implementation because I'm only calling through to actual class methods as opposed to using reflection to make the calls, which, again, messier, dependent on typing on the keyboard correctly. And so what I'm going to walk through here is doing this just solely with reflection. It's the method I'd recommend and the method that I prefer. So this time, all the action is going to focus on my canary class. So I've got my canary, and as I said before, there are a couple different ways to do the detection phase, and I'm using a different one here. So I have my private member, which is now a method, the actual method type in Java. And then I'm using a static initializer block. So the static initializer block is going to run when the class is first loaded into memory. And in this case, what I'm doing is calling getDensity. So my getDensity member is going to be assigned the getDensity method of the canvas class if it's available. And incidentally, this method is only available on Android 1.6 and above, because before that, there was only one density in the world, medium density, on the G1. But if not, the class loading system is going to throw an error, which, again, I'll log and implicitly detect by leaving getDensity null. So then to actually use this in code, like I said, all the action is on Canary this time, and Canary is going to expose this interface that my other classes are going to call through to. And so I realize in this slide I left this extraneous hasDensity member, so please just ignore that. So in my getDensity method that Canary has, I'll first see, all right, did I find that the getDensity method of canvas was available? And if so, I'll just return the result from that, but I'll invoke that method using reflection, which means regardless of the system that I'm actually running on, Canary can be loaded. because I'm never calling canvas.getDensity. If I called canvas.getDensity directly, when Canary was loaded on Android 1.5, there would be an error thrown. So I've met my goal of fewer classes, but somewhat messier calling syntax here. But if Canary isn't available, I'll perform some default behavior. And in this case, default behavior is pretty easy to figure out because it is just to say that I'm on a medium density device, because Android 1.5, only medium density. What you may choose to do with your applications instead is to either disable whole sections of functionality, or to try to run in some degraded mode when you don't have access to APIs that you would like. And so by using these, somewhat clever, somewhat not clever tricks with reflection, you'll be able to detect the environment that you're running in, and then at runtime adapt your behavior accordingly, and meet this goal of having the second vector of compatibility, this version level API compatibility. So now, having talked about the two vectors, I just want to say a couple words on testing. Testing is always important for any code that you write, but certainly if you're writing tricky code that uses reflection or providing different resources, you want to verify that all of this works properly. And there's really nothing better than actually testing your application. It allows you to verify that the UI that you've designed for different screen resolutions and different screen sizes and densities is working properly. And also check that the API compatibility code that we just went through is working as expected. And the great thing is that you can do pretty much all of this checking on the Android emulator itself. So for some of you, you will be writing applications that access bits of hardware that the emulator doesn't, emulate. Maybe it's the Bluetooth stack or using Wi-Fi or something like that. In which case, you probably will need a bit of hardware to actually do your testing. Oh my God, he admitted you might need hardware for testing. But the happy news there is that you don't need every piece of hardware in the world. So as I've said before, the Android system tries to simplify the view of the device universe, particularly with respect to screens, into some different buckets. So at most, what you need is hardware from each of these different buckets. And there really aren't that many buckets out there. So no need to run out and buy all 50 phones that you see on the show floor or so, although I'm sure the OEMs would love it if you did. So support our OEMs. So I hope in this presentation you've seen that supporting all these different device models that will reach millions and millions of users is not a Herculean task, but one that is imminently within your reach. There are these cluster of considerations to think about while you're building your application. And if you take these to mind as you're writing your code and designing your resources, you're going to end up with an application that looks great across all those devices in the hands of millions of users. So with that, I'll turn it over to questions. Again, here's the URL for the live wave and the QR code, which I will leave up for just slightly longer this time. OK. And I'm going to try to switch over to Wave here. And see what we have in terms of questions. If there are live questions, please go to the microphones, and we'll try to multiplex in some efficient way. How to target devices like a pad? Android pad. I haven't heard of the Android pad. I don't think it exists. So, sorry? So someone's talking about the lobby of Building 43, and I believe you're referring to what we call the megaphone, which is, if you haven't seen pictures, of a life-size kind of Nexus 1. So, I mean, the answer is there is no APAD, but I can actually answer this question for you, which is to say, use all of the things that we've been talking about here. If you think about this, anything that is sort of a tablet-sized device just has a different screen configuration. And we have the resources in the system for you to be able to deal with this. So I'm going to go to a live question over there.
Yeah, one of the things that I ran into in trying to handle the rotation, for example, was I have an application that solves puzzles. And it takes a while to do that, and it does it in a thread in the background, and is constantly showing, updating the screen. So if you do this, the normal, let the application or let the system kill the activity and restart it, you lose your UI context that the background thread is trying to access through the handler. How do you deal with that?
But you're still preserving your thread running in the background, I assume.
That's correct.
OK, great. So you're doing that. And before I answer your question, I want to talk about how you're probably doing that, which many, many devs I've talked to aren't aware of. And so that's this great callback called on-retain non-configuration instance. So if you're handling a configuration change and you've got long-running stuff solving a puzzle in the background, you can shove that running thread into the object that is passed along to on-retain non-configuration instance. And that thread will keep running and keep spinning away while the orientation or something else is changing, and allow you to not do all these nasty tricks like storing things in static members. So to answer your question, how do you deal with a lost UI context? And I don't think there's any magic answer here. You basically need some bit on that thread, that you can set on that thread to say UI unavailable. And then when the UI comes back, what you want to perhaps have is, so one way perhaps that you want to structure your puzzle solver thread is to actually have a looper of its own. And have that looper be able to receive the message from the main UI thread when it comes back. So have something in onCreate that will be able to get to that handler and send it a message. And that handler is something that you might want to store in that non-configuration instance object. And so then the thread will get the signal, OK, this is available again, and I can go ahead and update the UI.
OK, thank you.
Yep. So let's go over here on the other side for a question.
So I have a question. If you're targeting the other way, if you actually don't want to support all devices, are there any targeting options, for example, in the manifest, other than the version, the Android version?
So I actually had to forget that I don't have to repeat the question. You're on a mic. So the answer is there is a little bit that you can do. One is that you can say what screen sizes you support. So you can, for example, opt out of small screen sizes. Now, if you do something like opt out of large screen sizes, you don't actually opt out of them. Because what the system can do is say, OK, you were designed for a normal size screen. Well, I'll just letterbox you because I can run you in the context of this larger size screen, and you're going to perform like you're expected. Like you're expected to. Conversely, with small screens, we can't take a large interface and cram it into a small screen nearly as well. So there are a limited number of options here. And I guess I would really hope that the focus is on bringing Android applications to all the users out there. I certainly understand that sometimes not all devices can be supported from the beginning. And you may be left in a situation where you'll just have to do runtime detection and say, I'm sorry, I don't support your configuration. And the other thing to be aware of with this is that this ability to filter and target is actually at the Android market level. So the screens attribute that I was talking about, for example, is completely ignored by the package system. So it won't, refuse to install something that doesn't say that it supports this screen. It'll install it and then, try to run it and see what happens. So, it's just something to be aware of, that if you're delivering an app through your own website or something like that, you may not have that same sort of protection that Market affords you.
Thanks.
Sure. So I want to go back to a question on the wave. How will future versions of Android address fragmentation? Well, so first of all, let's define fragmentation. And so fragmentation is when the same version of Android runs differently across different hardware. And so to date, I haven't really seen that many instances of fragmentation. I suspect the asker of this question was asking, how will we address the fact that Android runs on devices that aren't the same? So the answer is, we're not going to stop Android from running on different devices. Running on different devices is great. It allows people to put different phones, all sorts of things out there that meet the end user's needs. The end users want different types of devices. They want different configurations because they meet their needs better. So what Android already does and will continue to do for you, and try to do better and better as time goes on, is allow you to understand the environment in which you're operating and adapt to it appropriately, and provide tools where it can. For example, where I was talking about image resource scaling before. This is something provided by the system so that it's easier to run on different screen densities out there. And where we can provide these things that will help will help developers out, we will implement them. So mine is not being refreshed. So I don't know if that answered the questioner's question. If they're here, raise your hand, and if it didn't, we'll. OK. OK, let's do another live question over here.
I just wanted to point out that there's a better way to handle the case or detect the case where a method has been added on a newer version of Android.
I'm sorry, to detect where what has been added?
The case where a method has been added on a new version.
Sure.
You can actually use the same way that you detected a new class has been added. You can just catch the verify error.
Mm-hmm.
I used that in Hello Android 3rd edition when I wanted to support multi-touch and also not multi-touch.
Mm-hmm.
So I just had a class which extended move events, and if you were on an old Android, it got a verify error which you could catch.
Sure. And yes, that's another way that you can do it. And certainly I was hoping to bring out a number of different ways to skin this cat that, if different people have different exact use cases and situations, they can choose from the one that makes the most sense for them. But yeah, that's a good point. You can use very much the same method as for the whole new class to do a method. OK, so last question. So raise your hand if you So raise your hand if you want me to answer the first question up here or take another audience question. So question up here. Raise your hand. Audience question. Audience wins. You, sir.
Me.
Yes.
OK. So mostly from listening to your talk, it seemed like you were addressing graphical objects, icons, drawables, images, 9 patches, things like that. I have an issue where an app that I wrote for the G1, I actually didn't write it for the G1. It runs properly on the G1, displays an edit text view properly on the G1, but on the Droid, it collapses it and it cuts it off, and things just aren't lining up. So I was wondering if you have any advice or hints for not graphical objects, but regular UI objects?
Sure. So, I mean, you know, the edit text is in some sense just a drawable object itself. Now, this actually is also sort of the first question up here. What if things behave differently on different devices? And so if things behave differently on different devices, it's a bug. Report that bug. Report it loudly if you need to.
Okay.
But report
I'm reporting it.
So now, in your specific case, are you perhaps defining the size of the text that goes into the edit text in number of pixels, px?
I would have to go back and look at my XML file. I think I'm defining it in terms of DIP.
OK.
I recently went through my XML files and kind of did a purge on PXs and replaced everything with DIP. There may be a straggler out there, but I think it's all working off of DIP.
OK. So then the answer is that I'm not aware of that bug. So report it on the forums and whatever, and we'll pick it apart. So the specific issue, though, that I'm talking about is if you define things on PX, there was a bug in at least one version of Android that ran on Droid, where the number of pixels that correspond to a PX was incorrect. Okay. And so any text that you find in terms of PX would render incorrectly, but I think it's only fair because we tell you not to use PX. Okay. And use DIP, DP, or SP.
And just to clarify one of the very first questions, there actually is a device out there called the APAD. This is like came out on some of the gadget sites about a week ago. If you Google for Android and APAD, there is a Chinese knockoff company out there who is selling a generic tablet device running Android 1.5.
Does it look cool?
It looks pretty freaking cool.
OK, I'll have to look it up. So we're over time, and they're going to shoot me pretty soon. But thank you all for coming, and enjoy targeting all those devices and the users that come along with them.